Good morning, everyone. My name is Banu Prakash Veera. Today, my topic is Fourier series and the types of Fourier series. First one, trigonometric Fourier series, exponential Fourier series, cosine Fourier series, and distress conditions. Let us see one by one. Introduction to Fourier series. Fourier series helps express periodic functions as sum of sines and cosines, and it is developed by Jean-Baptiste Joseph Fourier. It is useful in signal processing and vibration of signals and heat transfer, etc. Introduction to Fourier series means Fourier series helps the express the periodic function like f of t equal to cos omega plus sin omega t. It is developed by the Joseph Fourier. For the periodic Fourier series is useful for signal processing, vibrating analysis, and heat transfer, etc. Let us see what is periodic. What is periodic function? A function f of t is periodic if f of t plus capital T is equal to f of t is where capital T is the time period. Fourier series breaks the periodic functions into simple harmonics. Key idea is approximate any periodic function using the sine and cosine terms. It means the periodic function we use as sine and cosine functions, etc. into simple harmonic functions. Trigonometric Fourier series. First one, general form. F of t equal to a naught plus summation a n cos n omega naught t plus b n sin omega naught t. We know that the Fourier series means sum of cosine and sine. Let us say a naught means a periodic function and a n means for Fourier coefficient and cos and omega is sine and cosine function where omega not equal to 2 by capital T. Omega not equal to fundamental frequency and T capital T means time period and an comma bn are Fourier coefficients. Calculating the coefficients of trigonometric Fourier series. A naught equal to 1 by t of integral f of t dt. An equal to, this is the general formula of a naught, and an equal to 2 by t into integral f of t into cos omega n omega naught t dt. Bn equal to 2 by capital T integral minus f of t and sin omega naught t. These are the two formulas of a and bn, and it means it is the a and bn are coefficients of Fourier series. And we calculate a naught and an and bn. We add the a naught plus an plus bn. Exponential Fourier series. F of t equal to summation Cn e power cap j omega naught t, where Cn equal to 1 by t integral f of t into e power minus j n omega naught t. T is the general exponential Fourier series formula. Exponential Fourier series provides a compact representation using complex exponentials. F of t is the periodic function and Cn is the coefficient of exponential Fourier series. Cn is the general form of exponential Fourier series. Advantages of exponential form. It simplifies the mathematical manipulation, especially in differential equations. It means it simplifies the simple mathematical form into general form. It is especially differentiations and integrations. So it represents the symmetry between positive cycle and negative frequencies. usually in engineering applications like Fourier transform. Exponential Fourier series form simplifies the mathematical forms in simple waveforms, and it is compare the between the positive and negative frequencies and what is their amplitude and function, and usually in engineering applications like Fourier transform. And first we know that cosine Fourier series are even functions. Cosine Fourier series, it is also called even functions. For even periodic function f of t equal to a naught plus an cos omega naught t. In this cosine Fourier series, only cosine terms are present. Eraser to compute for even symmetric signals. For easier to compute the even symmetric signals, in this cosine Fourier series are used to compute the only even function signals. It has only cosine term cos n omega naught t. F of t equal to a naught plus summation an cos omega naught t. This is the general form of cosine Fourier series. And we know last we can go for the distress conditions, means convergence criteria. We note that f of must be in periodic, f of must be absolutely integrable over a period, f of t must have infinite number of discontinuous, and f of t must have finite number of maxima and minima. These are the distress conditions of conditional. It is also called convergence criteria. F of t must be period, f of must be absolutely integratable over a period, f of t must be have a infinite number of discontinuities. F of t must have finite number of maximum and minima. These are the distress conditions of Fourier series. Physical interpretation of distress conditions ensure the series approximates the function well. In practice, most physical signals satisfy these conditions. A discontinuous series converges to average of left and right limits. These are the physical interpretation of distress conditions. In practice, most physical signals satisfy these conditions. A discontinuous series converges into average of left and right limits. In practice, most physical signals satisfy these conditions and ensure the series approximates the function well. A discontinuous series converges to average of left and right limits. Application of Fourier series. It is used in signal processing and audio compression and heat transfer analysis, vibration analysis, and electrical engineering. It means signal processing means it is used for the any noise in the signal it is defined, and audio compression we use it to we will compress the audio like compress the audio between amplitude and compare of amplitude and frequency, heat transfer analysis, vibration like sound particles, and it is used in electrical engineering. And conclusion and difference. Fourier series is powerful for analyzing periodic signals. And different forms like trigonometric, exponential, cosine suit different problems, and distress conditions ensures convergence. and it has a different forms like trigonometric Fourier series, exponential Fourier series, cosine, and a different problems. Distress conditions ensure the convergence. Let us see differences. Fourier series theory like we refer to the theory books like textbooks and online engineering resources. Thank you.